you. Okay, so before we start, any questions from anyone? Questions? Okay.
Wait, on the homework?
Sorry?
On the homework,
Yeah.
it said that the cube is not a surface. I got that wrong.
Okay, so okay, it depends, right? Cube has a surface. The surface of the cube is different from the cube itself. Is the cube is like the whole volume? Okay, it depends. If you are talking about cube as just a surface of the cube and it's a cube, then you can call it a cube. Okay, ultimately it's the naming, right? Typically, when you call about when you say cube, you mean the whole cube, not just the surface of the cube. Is that clear? I mean,
What's the difference between a sphere then?
Oh, sphere is like this. The surface of the sphere is a sphere, right? And the inside is like, it's not called a sphere. It's called a ball, right? I mean, okay. Is that okay? It's really a matter of naming. I can give it to you if you want. It's not really a.
No, it's okay. But
Yeah.
I just want to. It's okay.
Yeah.
wanna...
Yeah. Okay. That's not really. Yeah. Okay. So I can change it. It's not really. I can remove that actually if it's ambiguous. It's not. Yeah. Maybe I should have said explicitly the surface of this cube or the whole cube or something like that. Okay, so I mean, like, there's a difference between the surface of the cube and the inside of the cube. That's all I mean. So when I mean cube, I was referring to the whole cube in the options. If you are thinking of the surface of the cube, then yeah, then it's a surface. But also in general, it's the surface of the cube is also not called really a surface because you have it's not smooth, like, right? You have all this, like, sphere is a smooth thing, but like surface of the cube is like more like it has these edges, corners, so that's why it's not really called a good surface. But yeah, it's really a matter of naming. Okay, I should have. I can change it if you want, but yeah. Okay. Any other questions? Okay, so important stuff. So you have midterm next week, the first midterm. So we sent out some announcements. Please make sure you read all the announcement, so read the emails, okay? Read the announcements. So you have all the details and like the rules that you need to follow for the midterm, how the exam would go through. So it's on all Canvas, so all sections Canvas site. So this is really important. The exam happens on all sections. It's not on this side that we use for our sections, but it's all sections. So it's a coordinated course. So you'll be taking exam with all the people taking 251. So it's all section site. Okay, so that's one information. And to be able to take the midterm, you need to make sure that your proctor track is on. Still, there are like 10 students who didn't fix this issue. Please make sure that you fix your proctor track problems. And okay, if you guys don't have access to all sections, you're supposed to have access to all sections. If you don't, then you're supposed to just email me and we will discuss. Like, I'll put you in the site. Okay, so that's one information, proctor track. So please read the instructions. So your exam will not be just like the quiz that we have seen. It will be like a quiz that I'm going to post today and the quiz that you're going to do this week, in the sense that you have to use some features of the quiz and the assignment section. So it's slightly different, so you'll get used to it. I'll post a sample quiz so that you can work on that. What else? Proctor track. So again, so if you have any other issues, like if you have issues with MyLab access or something, please, okay, if you have technical issues, send the technical support or the Pearson support an email. But if you have any other issues, send me an email about MyLab. So that's one thing. And yeah, so I hope you're working on your homework. That's really important, like the online homework and also the sample problems, so that you'll be able to do your midterm. So yeah, the midterm is on the 12th chapter and 13.1 sections. Okay, so that's some information. Yeah, I guess that's it about technical stuff. So please make sure that you are practicing. So I posted some exam guides and other resources for you to practice. So please practice problems on these sections. Okay, so anyway, so last uh, class we were discussing about dot products and cross products. It's a way to multiply vectors. So dot product is somewhere v dot w, cross product is v cross w, and dot product, as I said, it has a nice formula. In terms of the coordinates, and it can also be defined. This is the algebraic way to think of it. If you have some coordinate, if you know the components, you can just compute the dot product like this. If you want it to relate, if you want to relate it to geometry, then you use this: the length of the vector v, length of the vector w times cosine theta. Theta is the angle between these vectors. Okay, so these are two important ways to think about dot product. Okay, so let me start. Okay, so this is the two important ways to think of a dot product. As I said, you have dot product of two things, algebraically computed with this kind of expression, and if you want to relate to the angle between the vectors, this is the formula: u dot v is length of u times length of v times cosine theta. So this is u, this is v. So if this is theta, this is the formula for the vectors. Okay, so that's why dot product we see is related to the angle between the vectors. So dot product is related to the angle between the vectors, and somehow the cosine of the angle, or it's related to the cosine of the angle. Also, we see that the cosine of the angle between the vectors is related to the projections. So you need to know how to compute the length of the projections. So if you have this vector v, if you have this vector u, the same picture. So if you have cosine theta, so this is u. So u cosine theta will give you the length of the projection. So that's why somehow u dot v is related to the length of the projection. So in fact, it is u dot v. It's not just u dot v. U dot v will give you uv cosine theta, but the length of the projection is just u cosine theta. So that's why you divide by v to get the length of the projection. Okay, so that's one more information about dot product. So these are the main ideas. So it's related to the length of the projection, and it's also related to the cosine of the angle. Both of them are geometrically related, essentially. And why do we care about such things? Projections are important quantities in general that you see. This computing these lengths of these projections. So this is called a projection. Like if you have this vector, you kind of imagine that you're shining light or something from the top, then you'll see that this is the projection length. So you're interested in these kind of quantities in general in geometry. Also, a lot of physical, if you do physics or any kind of more real world stuff, you'll see that dot products appear in in terms of many quantities. For instance, work, the idea of work and an energy are related to this dot product. It's the dot product of the force and the displacement vector. Okay, so that's the story of dot product. Okay, a formula in terms of the components, how it relates to the angle between the vectors. Okay, similarly, the cross product, it's slightly different. It's instead of cosine theta, it's related to the sine theta. So u cross v now is u times v times sine theta, but it's not just that, it's times a vector. So that means that this whole thing is a vector, right? So the cross product is a vector. And so what is the direction of that vector? So the direction of the vector is given by the right hand rule. Okay, so you move your fingers from u to v, then your right hand thumb will point towards u cross v. Okay, if you're moving, keep your palm on one of the vectors and you move your fingers from u to v, then you get the direction of your thumb is the direction of u cross v. So in this picture, if you move from u to v, you'll see that your finger will point upward. So that's why u cross v is in the perpendicular direction, upward direction. Similarly, if you want to get v cross u, you have to move from this direction to this direction. So that means you have to put your hand in the opposite direction. So if you try to do u cross v, your finger will point downwards. So that's why, sorry, v cross u, your finger will point downwards. So v cross u has the direction which is downwards instead of upwards. Okay, so that's the information about cross product. So I'm giving you the geometric definition. So u cross v is directly related to uv sine theta, related to the angle between the vectors times this, and its direction is given by this right hand rule. Okay, so the first part gives you the magnitude of the vector, second part n is just the direction, and that's defined by the right hand rule. Okay, and cross product, as I said, as like typical rules, you can multiply things out, you can just distribute things, and this important thing, u cross v is opposite sign of v cross u, because as I said, v cross u and u cross v have the same magnitude, that's uv sine theta. The only difference is that one is in the opposite direction of the other. And similarly, you can distribute normally like you do for numbers, v plus w cross u is v cross u plus w cross u. And if you try to take the product with a zero vector means a vector which has zero magnitude. Okay, so that if you take a product with it, you get a zero vector. You can see that one of the values is zero. If the length is zero, the whole thing will be zero. Okay, so some examples. So what is the cross product of I and j? So I is the vector along x-axis, j is the vector along. So I is along x-axis, j is along y-axis. So what is the cross product of I and j? Can you guys tell me what is the cross product of I and j? Yeah, so I and j. So if you try to take the cross product, it has to be a vector in the direction perpendicular to I and j, and the length of the vector I is 1, the length of the vector j is 1. So, and I and j are perpendicular to each other. So if you compute I, j sine of 90 degrees, you get 1. So 1 times the direction of the vector will be perpendicular to I and j. So that will give you k. Okay. What about j and k? This is say k. If I take the cross product of j and k, what do you get? I, yeah. So imagine, so in this picture, imagine that if you're taking the cross product from j to k, you'll see that your finger will point towards I. Okay. So I can't show it to you here, but imagine moving j to k, then your right hand finger will point towards I. So that's why it's I. Okay. What about I and k? If I try to take the cross product of I and k, what would be the direction? What would be the cross product of I and k? Okay, it's related to j, but it's not exactly j. Yes, if you try to imagine taking the product, so you're moving along this direction, so the cross product will be towards the bottom of the picture. So I cross k will have the direction which is opposite to the j vector. So it's minus j. Okay, so it is along j, but it's not exactly in the direction of j. So it's the opposite direction of j. So if you move from I to j, you'll see that your finger will point downwards. So it's minus j. What about the cross product of I and I plus j? What is the cross product of I and I plus j? Anyone? Yes, it's k y. So I cross I plus j is nothing but I cross I plus I cross j. Should put arrows everywhere. Okay. So I cross j is k from the previous stuff. So I cross j is k. What is I cross I? What is I cross I? The second term is I cross j, which is k. What is I cross I? Yeah, it is 0, because I cross I is nothing but I has, as I said, the cross product of two parallel vectors is 0, because you have u v sine theta. When theta is 0, you'll get that the vector is 0. So that's why it's 0 plus k, hence it's k. Okay, so that's k. Okay, so please make sure that you understand these things. Okay, again, so for computing the magnitude, you compute by this uv sine theta, but for computing the direction, you have to make sure that you do your right handle. Okay. Okay, again, I'm repeating this. If u and v are parallel, then the angle between them is 0. So sine of 0 is 0, so u cross v will be 0. For parallel vectors, the angle is 0 between them, theta is 0, so the cross product will be 0. Okay, so but we are defining it in terms of u, v and sine theta, but what does u, v, sine theta represent? If you try to compute the area of the parallelogram, you draw u and v and you compute the area of the parallelogram, you will see that it is u, v, sine theta. Why is that? So the area of the parallelogram is given by the height times the base here. The base has height u, so length u, and the height has height here can be computed as v sine theta. So this is v, so this is theta, so the height is v sine theta. Okay, so the base is u and the height is v sine theta. So that's why the area of this parallelogram is base times height, which is u v sine theta. U is the base, v sine theta is the height from the picture. So this is v, so this v sine theta would give you the height. So the area is u v sine theta, which is nothing but the magnitude of u cross v. So what does that mean? If you try, so this number that we compute when we compute the cross product is the area of the parallelogram given by u and v. Okay, so any two vectors, if you compute the cross product, it computes the number, the magnitude of the vector that you compute is the area spanned by like the parallelogram containing those vectors. Okay, so that's one information, and it's so, but u cross v is not just that number, it also has the direction. So it is the area with a added with a direction. So area is, the magnitude is given by the area and the direction is given by a vector which is perpendicular to both u and v. So is that clear? So it's for any u and v, you try to find a vector perpendicular to both u and v that will be parallel to u cross v. Okay, if you want to find a vector perpendicular to u and v, it's u cross v will be the vector that's perpendicular to both u and v, right? Because u cross v is exactly is defined like that. So it's the direction of the u cross v is just perpendicular to u and v. Draw a perpendicular, take the plane and take the perpendicular vector to both u and v. That's the vector that is along the direction of u cross v. Okay, so now we discussed the geometry of u cross v, but now let's try to see how to compute u cross v, right? So for instance, I gave you the formula for dot product in terms of the coordinates, how to compute dot product, but how do you compute the cross product? So for that, we need some formulae. So have you guys seen determinants before? Anyone? Did anyone see determinants? Okay, so let me quickly refresh what determinants are. If you have a matrix A, B, C, D, so it's just a data of numbers or symbols, anything, you can just put it in a bracket, and A, B, C, D is called a matrix. And this quantity that you compute, AD minus BC is called the determinant of that matrix. Okay, so if you take the product of opposite entries and subtract them, so AD minus BC will give you the determinant of the matrix, 2 by 2 matrix. Similarly, if you want to compute a determinant of a 3 by 3 matrix, A, B, C, D, E, F, G, H, I, it can be defined in terms of the smaller determinants. Once you know how to compute a determinant of 2 by 2 matrix, you can compute a determinant of 3 by 3 matrix by this formula. So what you do is A times, so A times this matrix that you get after removing A, the row containing A and column containing A. So A times the smaller matrix. Next, similarly, this is B times next is minus B times if you try to draw, if you remove these two elements, you're left with D, F, G, I. So that matrix, if you plug in, you would get so minus B times that smaller matrix, plus similarly plus C times this matrix that you get by deleting that rows containing C. Okay, so that's the formula for the determinant. Is the formula clear? So what is the reasoning between minus sign? So okay, I mean I can define many things. I can also call I'm calling this some number, right? This is a number I like. Okay, so I mean, why am I computing these numbers? For instance, why do I have a minus here? Or why do I have a minus here? This is the only choice of this is the only formula that actually gives you some geometric meaning. Okay, this is the formula. If you do anything else, that won't have any geometric meaning. So that's why we do it. Okay, so if you think I can try to explain more, but that's roughly the. So that needs more discussion about determinants in general, so areas and volumes and so on. So, but for you, the thing I want to say is that, okay, you can write so many formulae, but there are only some formulae which have some meaning, right? It's geometric meaning. So this specific formulae are the only things that have geometric meaning. If I make a minus to be plus, then you would not get any meaning out of it. Okay. So, okay, let's see. So what is the determinant of 1, 2, 3, 4? Okay, so let's compute it. So determinant. So this determinant is nothing but 1 times 4 minus 2 times 3, right? You multiply diagonal quantities and subtract them. 1 times 4 minus 2 times 3. So this is 4 minus 6. So this is minus 2. Okay, so that's the determinant of 1, 2, 3, 4. Okay, so next, what is the determinant of 1, 2, 3, 1, 0, 0, 0, 1, 0? Okay, so let's compute it. So determinant, as I said, you first take this is defined by first take 1. So 1 times, you then remove the row and column containing 1. So you remove this and this, you're left with 0, 0, 1, 0. Next, you take the second element, so minus 2 times 1, 0, 0, 0. Next, the third element, 3 times, if you remove 3, okay, so if you remove 3, you're left with this. So this is 1, 1, 0, 0, 1. Okay. So that is the determinant. So can you compute what this is? Okay, the first determinant is 1 times 0 This is 0 times 0, 0 minus 1, 0 times, so 0 times 0 is 0, minus 0 times 1 is also 0. So it's 1 times 0. The second determinant is minus 2 times 1 times 0 minus 0 times 0. It's also 0. Plus 3 times, this determinant is 1 times 1. This determinant is 1 times 1 minus 0 times 0. So this is 1. Okay, so it's 0, 0, and 3. So you get 3. Okay, so please make sure that you know how to compute these determinants. Okay, so why am I talking about the determinants? So determinants are really important quantities that you can see they're essentially related to volumes or the areas of things. So if I, somehow if you draw 3 vectors which correspond to these 3 columns, you'll see the volume spanned by those 3 vectors is given by the determinant. But yeah, for you guys, make sure that you understand these formulas. How am I computing the 2 by 2 determinant, and how am I using the 2 by 2 determinants to compute a 3 by 3 determinant, right? So the formula basically is this is called the Laplace expansion. So you compute a bigger determinant in terms of a smaller determinants, right? You compute a 3 by 3 determinant in terms of a 2 by 2 determinant. Okay, so again, so why do I care about cross determinants now? It's because, as I said, I know how to compute the cross product if I know the angle between the vectors, but I want to compute the cross product if I just have a formula for the cross product. Okay, so I know U is something, V is something, U is U1, U2, U3, V is V1, V2, V3, and we want to know what is the cross product. Okay, so it's simple, the formula, it's just U cross V is, you write down I, J, K in the first row and the coordinates of U in the second row and coordinates of V in the third row. So this gives you, and compute the determinant, and that gives you the cross product. For instance, you can write down the determinant here. So I times U, so this is nothing but I times the first determinant is U2, U3, V2, V3 minus J times U1, U3, V1, V3 plus K times U1, U2, V1, V2. So that's what you get if I apply the definition of determinant, and if I compute these 2 by 2 determinants and write down the formula, you'll get this is the cross product. Okay, so you don't need to remember the second formula. If you remember this is the basic formula. So if you remember that U cross V has this formula, then you'll be able to compute the cross product given the coordinates of the vector. Okay, so the example, so let's try to compute some cross products. Let's see, cross product of say 1, 0, 1, and say this vector, and say 0, 1, 1. Okay, so how do I compute the cross? Guys, can you see the screen? Did it? Hello? Okay, something happened. So give me a second, I'll reshare it again. Okay, just please let me know if this something like this happens. Okay, screen share issues all the time. Okay, so we want to compute the cross product of two vectors. So given two vectors, you want to compute those cross products. So the solution, so this is U, say, this is V. So U is given by 1, 0, 1. V is given by 0, 1, 1. So the U cross V would be just I, J, K in the first row, and then U in the second row, and V in the third row. Okay, so that's U cross V. So let's see what it is. So I times, so when you do the first right I, you remove the first row and first column. So you remove this. So you get I times 0, 1, 1, 1. And minus J times, you now remove the second row and second row. So you remove, say now you remove second row, second column. So you're left with 1, 1, 0, 1. And finally, for K, K times, remove the third row, third column. Remove the third row, third column. You're left with 1, 0, 0, 1. Okay. So you have U and V, right? I, J, K, right? U coordinates, V coordinates, and we are trying to compute this determinant. So if I do that, so you get this is nothing but I times this determinant is minus 1. So this is minus I. This is 0 times 1 minus 1 times 1, which is minus 1. Next, minus J times, this is 1 times 1 minus 1 times 0. So this is just J times 1. So it's minus J. Plus K times 1 times 1 minus 0 times 0. So this is just 1. So minus I, minus J, and plus K. Okay, so is that clear? How do you compute the cross products? It's simple. Just write down. It's not as simple as the dot product, but it's you have to compute this determinant, but still it's not that much. It's just you have to write down this determinant and just do some small computation to find your cross products. Okay, so I hope you guys practiced this already. So I did just practice few more problems, how to compute determinants and given how to compute cross products given the coordinates of these vectors. Okay. Now let's use this information to compute something else. So you want to find a vector. So there is some P, Q, and R are 3 points in the plane, in some plane, and you want to find a vector which is perpendicular to this plane. A vector perpendicular to this plane. So how do you think? Can you guys tell me a vector perpendicular to this plane? So assume that there's a plane like this, plane containing P, Q, and R, and you want a vector which is perpendicular to this plane. Right? There is some plane on which all these 3 points lie, and you want a direction which is perpendicular to that. Yes, so a direction perpendicular to this plane is nothing but if you take PQ and take the cross product PR, then the cross product of PQ and PR, so this vector and this vector will be perpendicular to PQ and PR. Okay, so is perpendicular, this is the idea. So it's perpendicular to the plane. Therefore, so that's what we need to compute. So compute the cross product. So can you guys tell me the cross product? So PQ, what is PQ? So to compute the cross product, first we need to know what PQ is. So what is PQ? The vector. I know what P is, I know what Q is. How do I find PQ? Yeah, you subtract those coordinates. So it's 2 minus 1 is 1. 1 minus 1 is 2, minus 1, 0 is minus 1. And similarly, PR, what is PR? It is just R minus P, so minus 2, and 2. Okay, so now just take the dot product of these two vectors, so cross product of these two vectors by the determinant. So let me do it. So PQ cross PR is nothing but I, J, K. PQ was 1. So PQ was, what was PQ? PQ was 1, 2, minus 1. PR was, yeah, you can do any of these vectors. You can do QP, QR, RP, RQ. All of them will give you the same kind of vector. I mean, they give you the same direction of the vector. The magnitudes might be different, but they will give you the same. Okay. The directions might also be different. You might get a plus or minus, but they all give you a vector perpendicular, right? So, I mean, a vector which is above the plane and below the plane are both perpendicular to the, so you don't really care about whether it's above the plane or below the plane. Okay, so 1, 2, minus 1, minus 2, 2. So this, if you compute this determinant, you'll get your answer. So let's see, what is this? I'm just writing down the answer. So this turns out to be 6i plus 6k if you compute, okay? So 2 minus is 2, j determinant is 0, the kth determinant is 6 again. Okay, so that's our, so this is a vector, so therefore 6i plus 6k is perpendicular to plane PQR, so plane containing PQR. Okay, so let's move to the next. Okay, so next, what is the area? So if I want to find the area of this, so the same points, PQR, I want to find the area of the triangle. So can you guys tell me the area of this triangle? How do I find the area of this triangle? Yeah, so if I do PQ cross, so let's see, PQ cross PR is the area of this twice the triangle. So it's the area of this parallelogram. This whole area is PQ, is given by PQ cross PR, right? Area of, as I said, the magnitude, if you compute PQ cross PR, you get the area of parallelogram. So therefore, triangle area is half of it. So that means it's half of PQ cross PR. Okay, so it's half of the magnitude of the vector PQ cross PR, which is, we found that it's 6i plus 6j, 6k. So can you guys tell me what is the magnitude of 6i plus 6k? Right, there's a vector 6i, 6k. How do I find the magnitude of it? Right, it's the coordinates are 6, 0, 6. So it is square root of 6 squared plus 6 squared. It's the magnitude of 6i plus 6k, and there's a half outside. So this is right? This is square root 72 over 2, or like you can simplify it. So this turns out to be 3 square root 2. Okay, is that clear? As I said, cross product will give you the area of the parallelogram. If you want to just find the area of the triangle, you should take half of it. Okay, so that's one example of how to use cross products. And the physics example is that if I have forces and if I am applying a force not at from a different position, like if like there's a pivot and like I'm applying a force, imagine that I'm trying to rotate some rod, or like if I'm trying to, yeah, there's a fixed rod, a rod that is fixed at P, and I'm trying to give a force to rotate that object. So you want to know what is a torque. There's something called torque in physics, which is about trying to understand how much rotation that you can cause uh, if I apply a force, right? So because one of the point is fixed, it can't accelerate, it can only rotate. Um, so so if I fix P here and try to apply the force at Q, then this whatever bar can only rotate. So you want to understand what is the uh, tendency to rotate. Just like force is the tendency to, I mean, it gives you accelerations. This will give you the tendency to accelerate. How can cross product represent both the directional vector of perpendicular to the plane and twice the area? Oh, okay. So let's see. So cross product as a vector will give you the directional vector of the perpendicular, but the magnitude of it will give you the area. So this is a vector, that means it has two things, right? It has a direction and it has length. So the length or the magnitude of that vector will give you the area of the parallelogram. Is it clear? So if it is some, for instance, if you take the vector k along k, you can have a lot of vectors perpendicular to the xy plane. Every vector 100k, 1000k, minus 1000k, all of them are perpendicular to the xy plane, but only some of them will have the right area. For instance, the area spanned by I and j is uh, the parallelogram is the area of the square, that is just 1. Only for the vector k, you have the area which is equal to uh, magnitude which is equal to the area of the vectors you're taking the cross product of. Okay, if I change PQ to QP, yeah, so you can take any vectors, it will be the same. So you can, instead of taking P as your base point, you can take any other points as the base points. That doesn't matter. You can change QP to PQ, yeah, it doesn't matter. So you'll get negative sign in the vectors, but when you take the magnitude, you will all get the same numbers. Okay. Again, so in physics, there are important quantities. This is called torque. It's just defined as R cross F. Okay, I don't want to discuss the details of why we care about torque and stuff. So this is something that if you are interested in physics, you'll learn this. So this is an important quantity in physics. And to actually use it, you have to compute the cross product. Okay, so can you guys tell me that there's a force F in this example? Okay, of magnitude 20 and r is the length of the vector r is 3 feet. Can you guys tell me what the torque is? Yeah, so this is r f sine theta times the direction. So let's see, r is 3, what was f? Oh, f was 20, okay. And the sine of the angle between those r and f. So this was r, this is f. So the angle between those vectors is this 70 degrees. So sine 70. Okay, so that's the answer, or times the vector. So the vector in this case is r cross f will be inside the plane of the picture that you see. So it's inside. So you have to go inside. So when you do r cross f, you will go inside the plane. So that is the direction of the torque, and the magnitude is 30 times 20 times sine 70 degrees. Okay, so that's how you compute torques, and these are important for physics purposes. Okay. So the next quantity that we would care in general, it's called the block. This is a quantity that's formed both of. We use both dot product and cross product to form this quantity. Wait, sine 250? What is sine 250? The angle between the vectors is 70. You take this, right? You have two vectors. You can see that the angle here is 70. So just map out the, try to just, so this was the vector. This is r, this is f. So the angle between them is 70. This angle and this angle are the same. Okay. Okay. So let's move on. So there's another new quantity that's called the box product, or the triple scalar product. So what does it mean? So it's something that's, again, it's defined. It's basically u cross v times dot. You take the cross product of u and v and take the dot product with w. That's called the box product. Okay, if you take u, v, and w, take the cross product of the first two quantities and dot it with the third quantity, that's called the scalar product of the boxed product. Okay, so how do I compute it? I know how to compute u cross v, I know how to compute v, and if I put them together, this will be the formula. Okay, so let's see how. So u cross v dot w is what I want. U cross v is nothing but I j k times u1 v1 u1 u2 u3 v1 v2 v3, that is u cross v, dotted with w1 w2 w3. Okay, so that's what we want to do. And if I expand this, this is I times u2 v2 v3 u2 v3 v2 v3 minus j times u1 u3 v1 v3 plus k times u1 u2 v1 v2. So that is u cross v, and if I dot it with the third vector, w1 w2 w3. So just write this down. So the coordinates of the first guy is u1 u2 u3 v2 v3. The next one is u1 u3 v1 v3. The third coordinate is v1, so u1 u2 v1 v2 dot w1 w2 w3. So if I put them together, this is nothing but w1 times u2 u3 v2 v3 minus w2 times u1 u3 v1 v3 plus w3 times v1, so u1 u2 v1 v2. Okay, so that's what you get if you take u cross v and dot it with third vector w. And you can see that this is nothing but u1, u2, u3, v1, v2, v3, w1, w2, w3. Okay. Okay, this is also related to, this also is in terms of the determinants. So you can see that that also is a determinant. So it's just, you have to verify that this expression is equal to this expression. Okay, so I'm just some algebraic computation. Basically, write down, I want to compute what u cross v dot w is, write down what u cross v is, write down what w is, and this just take the, and compute, write down everything explicitly, and if you compute, you'll see that that's equal to this determinant. Okay, so that's it. So that's called a box product. So if I want to compute u cross v dot w, I can just compute it like this. Write down the determinant u1, u2, u3, v1, v2, v3, w1, w2, w3. Okay. So why do we care about this box product? So somehow the box product gives you the volume spanned by these three vectors. Okay. So any three vectors will form the shape of a parallelepiped, just like two vectors form a parallelogram. If you take three vectors, you get a box shape, right? So this is the shape that you get. If you take three vectors, so they form like a cube, but not exactly a cube. It's a distorted kind of a cube. So you'll get this kind of shape formed by three vectors. Okay, my basic vectors are these. This is any three vectors gives you this shape. You can, once you have three vectors, you can form the shape, and you want to know what is the volume of that shape. And you can see that the volume of the shape will be the volume of the parallelepiped, because what is the volume of the shape? Volume of the shape is the area of the base times the height. Area of the base is u cross v that you have seen. Area of the base is the area of this parallelogram, so it's u cross v. And the height of this parallelepiped is nothing but is the projection of this w onto u cross v. Okay. So if I want to know the height, I need to project this w. So the w vector is slightly slanted, so I have to project the w vector onto the perpendicular so that I'll get the height. So that's why the volume is nothing but the area of the base, which is u cross v, times the height, which is nothing but w cos theta. So this is nothing but u cross v. This is the same thing as magnitude of, sorry. Yeah, so this exactly, if you write it down, is just u cross v dot w, the magnitude of it. Okay, questions on this? So if you want to compute the volume of this parallelepiped, you need to compute the volume of the base and the height. Volume of the base, or the area of the base and the height. The area of the base is nothing but we have computed, it's the cross product. And the height is nothing but the w times cosine theta. So where the theta is the angle between the perpendicular and this w vector. So you see that it's u cross v times w cos theta, which is nothing but the dot product of u cross v and w. So that's why this expression u cross v dot w will give you the volume of the parallelepiped. Okay, so any questions on this? Okay, so let me move on. So if you want to find the area of the parallelepiped formed by three vectors u, v, and w, so the volume is nothing but u cross v dot w, magnitude of it, which is u1, u2, u3, v1, v2, v3, w1, w2, w3, which is in this case 1, 2, -1, 0, sorry, this is -2, 0 and 3, and this is 0, 7 and -4. Okay. If I want to compute the volume spanned by these three vectors, you write down all those coordinates, and then the corresponding determinant. So then you can compute. If you compute this determinant, you'll get the volume. Okay. So in this case, I'm not showing you the computation. You can see that it's 23 units cubed. Okay. If it is in, if your units of this basic units, the length of I and j and k are some 1 unit, then this will have 23 unit cube of volume. Okay, because that's the determinant. If you compute the determinant, you get 23. Okay, so that's the story of cross products and dot products. Any questions on this? Okay, so let me move on. So, so to summarize what we have seen, it's just that so there are three quantities we have seen. So the dot products, which tell you something about the angles and also the projections. Cross product, which kind of is a vector. Now it's not just a scalar number. It's a vector. It gives you the direction perpendicular to the vectors that you care about, u and v. Then the cross product is perpendicular to u and v. And its area is equal, and the magnitude is equal to the area of this parallelogram. And third thing is u cross v dot w. This is called the box product, which gives you the volume spanned by the three vectors. You have three vectors. So the volume of the box formed by those three vectors is is the triple or box product. Okay, so questions? Any questions before I move on to the next section? Okay, so let's see. So the last problem, what? I didn't get you. Can you repeat the question, please? What do you mean by last problem, rectangular? Okay, you're trying to find the volume of these three. If you draw these three vectors and correspondingly draw the shape of the box that's formed by those three vectors, you'll get it's 23 cubed, 23 unit cubed. Okay, that's. Oh, so I'm saying if after, so this cos theta we don't use because the dot product already has the cos theta inside. If I try to take the dot product of this vector, u cross v dot w, that will already have a cos theta. I'm not just multiplying the length of u cross v and length of w. I'm taking the dot product of those vectors. Is that clear? It's not. This is the dot product. Okay. So this formula is a dot product. It's not just the length of the base area times the height. It's not just, I'm not multiplying the base area times the length of W. I'm multiplying the base area times the height, and the height is given by W cos theta. And to compute W cos theta, I use the dot product. Okay. So, so the next topic is about some surfaces, lines, planes, and so on. So we want to write down equations for lines and planes in the space. So you know how to write equations for lines in the plane. You have different, you should have learned in your school geometry about how to write equations of lines given different if you know how to write equations, if you have 2 points in the plane, how to write equation. If you know the slope and stuff, you know how to write equations. So you know different ways to write equations of lines in the plane. Now you want to similarly write equations for lines in the space. Also, you want to write equations for the planes in the space, and so on. Okay, so the main problem is to find equations for lines and planes. Okay, so again, the basic question is, how do you determine a line? So if I want to determine a line in the space, what do you need? I want to say this is a line in the space. What information do I need to know a line completely, determine a line completely? Okay, slope. So what do you mean by slope? Yeah, so there are different answers. Yes, you can take 2 points in the space and draw and determine a line. So 2 points is a good answer. Yes, or another thing is you have 1 point plus a direction. Okay, right? I can take 1 point to give you 2 points. That's one thing. Or you have 1 point and the direction. So both of them will give you different ways to determine a line. Okay, so let's see how to use this information. So first, I'll just try to do it in terms of a point and a direction. So if I know a point and a direction, so I can compute the line. So let's see. So I have point minus 2, 0, and 4, and this vector, which is the direction 2i plus 4j minus 2k. So I want to write down the equations for the point vector. So this is the vector, and this point is minus 2, 4. So can you tell me how to find the equations for, say, a point on this line? So a point on this line is here, P. This is the vector, and this you want to find a point on the line. Okay, so let's see how do you do that. So what do we know? So this is a point P0, say, right? So what does it mean? So if a point P is on that line, that means P0, this vector, is parallel to V, right? It's a parallel vector to V. So that means it's some T times V bar. Is that clear? So P0 is a vector for any point, for a point P on the line, right? P0 will be just parallel to the vector, the basic vector that you have. So that means P times P, like the vector P0 is just some scalar number, some unknown scalar T times V. So is this information clear? I'm just saying that P0 is parallel to the vector V, right? So P0 is this vector, and the vector V that's given is just, so it's parallel to this vector. I mean, it could be opposite direction as well. In that case, T is negative. So it's like this or like this. So P0 is T times V. So, and T is some number, some real number. So minus infinity to plus infinity. Okay, so now how do I determine P? So what is P then? Can you tell me what P is? Okay, so what are the coordinates for P0? Is nothing but coordinates of P minus coordinates of P0, which equals TV bar here, right? If I want to find the coordinates of P0, you just have to subtract the coordinates of P and from P0 from P. So P has to be P0 plus TV bar. Which, okay. Oh, you can, yeah, so you have these coordinates, right? So you can, okay, P is a point, but you can think of this vector OP0 is a vector, T represents the scaling. So V is the vector that you are given. P is how much you need to scale that vector to get your point P. Okay, if you are scaling more and more, you get all the points. So you can think of it as like, if I stretch this vector continuously as t moves from minus infinity to infinity, you'll get all the points along that line. Right? 1v is something, 2v is something, 3v is something, 1.1v is something. All those numbers will just give you points along that line. Okay. Okay, P. So what do I mean by P minus P0? It's just subtracting the coordinates of P0 from P. Is this clear? I mean, we know that the coordinates of P minus P0 will give you the vector PP0. So if you subtract coordinates of P0 from P, you'll get the components of TV. Okay, so arrow. Okay, so we represent them by arrow because like you can think of P also as the point from 0 to P. So P was some say 3, 4, 5. So a point P that can be thought of. So you can think of it as a point, or you can think of this vector 0 to P, which has coordinates 3, 4, 5. Right. So this is called P. So vector which has coordinates 3, 4, 5 is called is written P bar, which is 0 to P. Okay. So ultimately I want the coordinates of 3, 4, 5, which you can write it as just a point, or you can write it as a vector. If I write it as a vector, it will be this vector. Okay, so that form of writing P is called that's the equation that gives you any point P. So any point P is just our basic point P0 plus some scalar number T times this vector V. So that's the basic equation. Okay, this is the equation in vectors. Now if you can write the equation, you can rewrite this equation into coordinates if you want. Right? So this is the vector equation, and I can write it in terms of coordinate, and I can see what you get. So for instance, similarly, so I wrote down the general expressions here. So a general point P, this is P, say it's called R of T, is given by a basic point P, which is given by R0 plus T times the vector V. So I was calling it P0 and P, here it's R0 and R. Okay, so this is, you can think of it as P of T as the vector, which is P0 vector plus TV. Okay, so just me erase this. Okay, so if you want to find the equation for a line, it's basically the point that you have, which is basic point P0 or R0 plus T times the direction. That gives you all the points on the line. Okay, if we take one point and you take and you add T times the vector, you are getting basically everything in that direction of that vector, starting at that point. Okay, so R0 is like the starting point, V will give you the direction, T will give you where on the line you are. Okay, so R0 is the starting point, V is the direction you are moving, T is how far you have moved, basically. Okay, so that's a vector equation. So in terms of vectors, that is the equation. But if I write that in terms of coordinates, so you will get something like this, right? So because R is just x, y, z are the coordinates of our point. R0 was the initial point, x, y, 0, plus T times V. V was V1, V2, V3. If I write this equation in coordinates, you'll have something like this. Now I equate both sides of that equation. You'll see that x has to be, the first coordinate is nothing but x0 plus tv1. X has to be x0 plus tv1. Second coordinate is y0 plus tv2. Third coordinate is z0 plus tv3. Okay, so that's how you get equations of the line. So if you have a point and a direction, you take the point plus t times the direction, which will give you the vector form of the points or the coordinates of the points together, all together. But if you want the coordinate wise, you write the same equation in coordinates, rewrite the equation in coordinates, right? Just explicitly write what r is. R is x, y, z, the coordinates. R0 is x0, y0, z0. V is v1, v2, v3. So if I write that and equate x coordinate, I'll get x0 equals x0 plus tv, x equals x0 plus tv1, y equals y0 plus tv1, v2, and z equals z0 plus tv3. So these are two different ways to write the equations. So this is called the vector form of the equation. This is called the parametric form of the equation. Okay, so if I want to write equations of lines, so it's in the first thing is vector form. The second thing is the parametric equation in terms of the coordinates. Okay, so this is the vector form. This is the parametric form. Okay, so as I said again, you can think of, so in the vector form, you can think of this R0 is the initial point where you start, T is like the time, and V is like the velocity. So, okay, so if you think of T as a time, if you imagine that you're moving along that line, a particle moving along that line, so R0 plus TV will give you the motion of a point along that line, and T will be the time of the after which you will be at that point. V will be the velocity. So and the velocity can be split as the speed is the magnitude of that velocity times the direction of that velocity. Okay. So R0 plus TV is nothing but the initial point plus T times V. V can be thought of as a direction, but the direction is basically the velocity of that point. If you imagine that there's a point moving along that line, you'll see that that's basically the direction along which it moves is the velocity of that particle. And so velocity, if you want to represent it using speed and the direction, is so V is a vector, velocity vector. It can be, so magnitude of it is some number. That magnitude of the velocity is called the speed, and the direction basically is whatever is left, V over V bar. Okay, so V can be written as the speed, which is V times V over the magnitude. So this gives you the direction, and this gives you the magnitude of the velocity. Okay, so those are three aspects or two aspects of the equation of the line. So let's compute some equations of the line. Find equations of line passing through, say 1, 0, 0 and 1, 2, 3. Okay, I want to find, so someone said, yeah, you need, if you have 2 points, you can determine a line, right? So I have these 2 points. So this is P here, and this is Q. I want to determine the line passing through P and Q. So what do I do? Yeah, so P is initial point. Okay, let's say P is the initial point, and Q P bar as the direction. Okay, so if I use P as the initial point, so P is nothing but 1, 0, 0, and similarly Q P bar is the direction. So the direction is nothing but if you compute, it's 1 minus 1, 2 minus 0, 3 minus 0, which is 0, 2, 3. So P is this much, QP is this much. So any point on the any point on the line is given by some r equals, so 1 0 0 this vector plus t times this direction vector. Okay, so the initial point plus, what do you mean there's a slope? Can you, if in the two, if you have two dimensions, there is a meaning of slope. But what do you mean by slope now? So 3 dimensions, a line can be in any lot of directions. Right? So there's no meaning for slope. Are you meaning, so you have to determine, like slope has meaning only if you have two coordinates. It's just because if you have just in the plane, the slope means how much you are rotated, right? The line. But here, it can, like there are so much degree of freedom. Slope doesn't really make sense in 3 dimensions. Okay, so that's why we use this equation. So this is the parametric equation. So R, so this is the vector equation. So this is the vector equation of our line. And if I want to write it in coordinates, this is x, y, z equals 1 0 0. So if I call r equals x, y, z plus t times 0 2 3, then if this is nothing but x, y, z equals 1 plus 0 times t plus 0 plus 2 times t, and the third thing is 0 plus 3 times t. So which is 1, 2t and 3t. Okay, so this, if you compare, so you get x equals 1, y equals 2t, and z equals 3t. So that's the equation of the line. This gives you the equations of the line. The 3 coordinates, 3 equations. Sorry, x equals 1, y equals 2t, and z equals 3t. These are the 3 equations. Okay, so that determines the so these are called parametric equations. So this t is called the parameter. So we don't know what it is. It's like the time parameter or like some scaling parameter. So parametric equations. Okay, so that's how you find the equations. Okay, again, so if you know how to use vectors, it's quite easy. So if you know the direction, basic direction v, and you want any vector in that direction, so starting from p0, so you use the information that p times p0, like the vector p0 is parallel to v. Parallel to v means that it has v times some number. So some number is t. So that is the basic idea. Okay, so if p and p0 are in the same line, so the line pp0 would be just t times v. Sorry, okay. So p and q are the points, and I'm saying the direction is qp. So that helps you to write our equation. So my any point would be the initial point plus t times this direction. This is the initial point 1 0 0 plus t times the direction vector. Okay, and that when I write it in coordinates, say the coordinates of my point r on the line is x y z. So if I write x y z, and that equals this left side, the right side 1 0 0 plus t times something. Expand it out. X y z equals this. You expand that expression and compare first coordinate, second coordinate, and third coordinate. X will be 1, y equals 2t, and z equals 3t. If I compare the coordinates, you'll get x equals 1, y equals 2t, and z equals 3t. Okay. Okay, so that's about the line. So we'll discuss more aspects of the equation of the line, and so I have slides written down already for the stuff that's going next. So please review, try to read the stuff. Yeah, so there's certain things like so you have the other quantities that you want to compute. We computed the equation of the lines. Then the things like we want to compute the distance between a line and a point. Then you want to write the equations of just not lines. You want to write the equation of a plane. So that's the next thing. And then you want to know when do two planes intersect? What are the intersections of two planes? So these are some, and what is the distance between a point and a plane? And you want to understand something like what is angle between two planes? And finally, there are some more, not just planes. If you want to understand some other shapes, what are the equations of those shapes? So there are these shapes that you have. You want to know what are the equations of all these shapes. Okay, not just lines and planes. Okay, so we'll do it in the next class. So it's already, I have slides for this already. So please have a look at them. Okay, someone is asking some question. So why is x, wouldn't x equals t? No, this is 1 plus 0 times t, right? So 0 times t. So 0 times t and this 1 here. Okay, so 1 plus 0 times t is just 1. Is that clear? This is 1 here and this t times 0. Okay. What about what is the equation of the line when a vector is perpendicular to it? So the point is okay. So you won't have one vector perpendicular to the line, right? Say for instance, if you have point P, this will be the direction of the vector along the line, but there will be so many directions perpendicular to the line. So there's a plane, like you can imagine. So if you have a point and this is a line, so imagine a line, you won't have one direction perpendicular to the line. You have a plane perpendicular to the line. So if you give me the plane perpendicular to the line somehow, then you can write equations for it. But we don't know, we don't even know what is the equation of a plane. So that's why we are not doing that. We'll do it next time. But is that clear? So I mean, the only information, if I want to say, there's nothing like a line of equation of a line with a given vector perpendicular to it. Right? If you give me a vector and if you say that the line is perpendicular to it, that won't determine a line. Is that clear? For any vector, there are so many lines perpendicular to it. Right? If I take this vector that I see, the whole plane here is perpendicular to it. So you can't really, this doesn't, so just one perpendicular vector won't determine a line through that point. You need like the whole plane of perpendiculars, then you will be able to determine a line through it. Okay. Okay, so please review this stuff. Okay, again, as I said, somehow the class moves very fast. We don't, unless you read the textbook and work through the problems, you wouldn't the ideas won't sink in. So please try to make sure that you're working on the problems. And I'll post a sample quiz and you'll have an actual quiz in the recitation. So so please work on the sample quiz so that you'll have a practice for how to attempt your quizzes and also the midterm. Yeah. Okay, which sections? So it will be till what we covered till today. Okay, it's basically 12.3 and 12.4 and like some maybe equation for a line list. Okay. So what kind of problems? As I said, so practice all those sections from your online homework and also the suggested homework. So I posted a midterm guide. So that should like for you to review stuff. So please try to work on all the problems in the midterm guide. Okay. The study guide that I posted on Canvas. Please review stuff from there. Okay. Any other questions?